This is going to be a full video representation of a code running for a Raspberry Pi project, which is supposed to be made on a physical plate, but I don't have access to it right now. So I'm going to show you the full steps of building and thinking of how everything works, the logic essentially. So let's start. So at the first part, as you may probably see here, is libraries we need to import for our code to run properly. It's requests, smtplib, and a time library. So the first one is a popular Python library that allows the program to communicate with the internet and fetch data from external websites and APIs. The second one is a library that comes built into Python and handles everything related to sending emails over the standard email protocol called SMTP. The third one, time, gives us access to a sleep function. And so basically it connects it into a loop, which we will use later to pause the program for a set number of seconds between each refresh cycle. Here, a program builds the web address it needs to contact CoinGecko, which is a free, publicly available cryptocurrency data provider, which is, for me, a trustworthy website, which have accurate prices and everything. So the URL includes several parameters that tell the API exactly what we want, provides prices in US dollars, a specific list of coins, and a percentage change data going back 7 days. The requests library then sends that request over the internet and provides a response. We call it JSON method on a response, which converts the raw text into a proper Python data structure, specifically a list of dictionaries, where each dictionary contains all the data for one individual coin. So next, what we see here is a guard clause. So before we do anything with the data we just received, we run a safety check on it. The instance function confirms that the response is actually a list, because if the API encountered an error, or we just send too many requests in a short period of time, it might return an error message instead of the data we expected. We also check that the list is not empty. If either of those checks fails, the program skips the rest of the current cycle, waits 60 seconds, and then tries again from the beginning. This makes the program resilient to temporary network issues or API rate limits without crashing. So next, what we do is a lookup dictionary. So the API returns coins in a list, but not necessarily in the order we want them. So how do we solve this? To solve this, we reorganize data into a dictionary called lookup, where each coin's unique ID string acts as a key, and the full set of coin data acts as a value. This means we can now access any coin information directly by name in predictable and reliable order, rather than depending on whatever order the API happened to return them in. Okay, then here we create a function while when we then loop through all 10 coins and extract the specific data points we need from each one, storing them into 5 separate lists. Every list follows the same order, so index 0 is a prices list, corresponds to the same coins as index 0 in the changes list, and so on. This structure makes it straightforward to process all the data given for a coin given by simply using the same index across all 5 lists at once. Then we start here is basically the brain of the code. This is the analytical core of the entire program. For each coin, we start with a source of 0 and then adjust it based on 3 separate factors. The first factor is a 24-hour change. If a coin has dropped by more than 3% in the last day, we add 2 points to its score, because its significant short-term drop can indicate that the coin is currently undervalued and may be worth buying. A smaller drop between 1 of the 3% adds 1 point. So the opposite applies if the price has risen, in which case points are subtracted. So the second factor applies the same logic but looks at the 7-day price range, instead giving us a broader picture of the coin recent trend. The third factor looks at trading volume. If a coin being traded more than 1.5 times the baseline volume while its price is falling, we add an extra point, because high selling volume during the price drop can sometimes signal that the market is overcorrecting and the recovery may follow. The maximum possible score is 5 and the minimum is -5. So here we have our scoring system. Once we have the final numeric score for a coin, we convert it into a plain English signal that is easy to read for a user and act on. So a score of 3 or above becomes a strong buy, and the score 1 or 2 becomes a buy. -3 below becomes a strong sell, and -1 or 2 becomes a sell. So anything sitting at 0 is classified as hold. meaning the data does not show a strong enough reason to act on either direction right now. So then we move forward to finding the strongest signal. This is here. After classifying all 10 coins, we run through them one more time to identify the single strongest opportunity in each direction. So we keep track of the highest buy score seen so far using the variable that starts at 0 and gets updated every time we find the coin with a better score than a current best. By the time the loop finishes, best buy holds the name on whichever coin scored highest, representing the strongest buying opportunity. At the moment, the same process runs in reverse to find the strongest sell candidate. So when SMTP email dispatch, when a signal worth acting on it is found, the program constructs and sends email. It opens a connection to a Gmail server on the port 587, which is the standard port used for sending emails securely. Then it upgrades to the connection to an encrypted and using a protocol called TLS, which ensures the login credentials and email content cannot be encrypted. After authenticating with the sender email address and app password, it formats the message according to the standard email structure. And that's it. So the entire email sending process is wrapped inside a try except block. This means that if anything goes wrong during the process, for example, if the internet connection drops, the credentials are wrong, or Gmail rejects the request, the program catches an error, prints a description of what went wrong, and so on. This is important because we do not want the entire tracker to stop just because one email failed to send. So then we come back to our main loop, which is a time library. The entire program runs inside an infinite loop, which means it repeats indefinitely until the user manually stops it. Yep. At the end of each cycle, after fetching data, calculating scores, printing results, and sending any necessary emails, the program calls time.sleep with a value of 60. This suspends the program for exactly 60 seconds before starting the next cycle, so giving the API time to update its data and preventing the program from sending too many requests in a short space of time. So let's see how it all look on a visual representation of running. We have our name, which is called the crypto trackers live signals. First, this of course asks for your email, which is going to be used for sending you all the necessary information. But overall, we have our market mood, so it's 10 neutral right now, and our top buy is Solana, top sell, no strong signal right now, and we all see on each coin which is right now the status of. We can all see all the changing. I'll now show you how it changes through time. So now we see a Bitcoin is on hold when it was on buy like a couple of requests ago. Now we see some of them have changed to sell, and now they're constantly changing their status to show the user that it's live, and it has the different statuses updated in the different periods of time. So let's start it over. Okay, we start with entering our email. Okay, so if I just enter my name, it will show me that it doesn't look like a valid email address, so it shuts down the whole program. So if we enter our email, actually, it confirms it and sends the data we want to look at, and the email is followed